Hello class, today we're going to talk about section 7.4, which is polynomials. By the end of today, you will be able to identify polynomials, write them in standard form to find their degree and leading coefficient, and then use polynomial expressions to solve problems. A polynomial is a monomial or the sum of two or more monomials. So before we were talking about monomials, there was no addition or subtraction allowed. Now we are allowing addition and subtraction into the mix. There are still no negative exponents in polynomials, and there are still no variables in the denominator. If it is one of those cases, it's not a polynomial. A binomial is a specific type of polynomial where you are either adding or subtracting two monomials. A trinomial is addition or subtraction of three monomials. When we are looking at the standard form of a polynomial, that means the terms are written from the highest exponent to the furthest left to the lowest exponent on the furthest right, and the leading coefficient is the number in front of the first term when it is written in standard form. So it's that number associated with the highest exponent term. The degree of a monomial means you're adding up the sum of the exponents. So numbers, so if you just have the number 5, for example, that's going to count as 0 when you are talking about the degree. The number 0 is a special case. It doesn't count for anything. So if you see the number 0, we're just going to ignore it. When we are looking at the degree of the polynomial, we are looking at each different one separately to decide what type of polynomial it is. If it's just a number, it's going to be called a constant. If it's got an exponent total of 1, it's linear. 2 is quadratic, 3 is cubic, 4 is quartic, 5 is quintic, and anything above that, we just use the number and refer to it as degree. So 6 would be 6th degree, 7 would be 7th degree, and so on and so forth. So, first, we need to identify a polynomial. So for A, I've got 4 minus 5xz. Both of those terms are monomials. 4y is a monomial, and 5xz is a monomial. They are being subtracted. So this is a polynomial, and specifically, we're going to call it a binomial because it is two terms being subtracted. Next, we've got just negative 6.5. That by itself is just a monomial. It is just a single number. Next, we've got 7a to the negative third plus b to the ninth. Well, we do have addition here. We have this negative 3. So this is not a polynomial because of our negative exponent. And then this last one down here, I've got 6x cubed plus 4x plus x plus 3. Some of you might call this just a polynomial instantly since we see 4 separate terms, but we want to pay a little bit more attention as these two terms, 4x and x, are similar or like terms, so we can put those together, which would mean we actually have 6x cubed plus 5x plus 3 because we can put our x's together. So this is actually an example of a trinomial. So when you are looking at these, you want to make sure that they are simplified before you actually determine the type of polynomial. Go ahead and decide what these two are. First one, we have a trinomial. There are 3 separate pieces, and our second one is a binomial with 2 separate pieces. If you have questions about identifying polynomials, please let me know when you get to class. Our next thing we have to worry about is standard form. So this is where we are paying attention to the exponents and rearranging so that the highest exponent is first. So if we're looking at this first expression, I've got 3x squared plus 4x to the 5th minus 7x. This 4x to the 5th has the biggest exponent, so that needs to be our first term. It is a positive value because it came with a plus sign. Our next term is 3x squared. Again, there was no sign and it was leading, so that is a positive term. And our last one is the negative 7x. So we are going to subtract that off of the end. The other thing that we want to do in standard form is identify our leading coefficient, or our LC. So we are looking for the number in front of our first term. So our leading coefficient for this one is 4. Similarly, with the next problem, we're going to start by looking for our highest highest exponent. So that's in the 3. So we're going to take negative 6y to the third comes to the front. That negative sign is associated with the 6, so we can't just bring it to the front and say it's 6y. That negative sign has to stay with it. Then we've got our negative 2y to the fourth is our second term, so we're subtracting those. Then we've got a positive 5y and a negative 9. Numbers always come at the end because they do not have a variable. Then again, we want to look for our leading coefficient, and in this case, it is a negative 6. The other thing that we're going to want to do with both of these problems is look for the degree of the polynomial. Once we are in standard form, we are looking at this first term to figure out the degree. To figure out the degree, we need to look at the exponent. So since the exponent is 5, our degree of this polynomial is 5. If we are looking at the second one, we've got a degree with our leading our leading term, which is going to be 3. Go ahead and try these two on your own, putting them into standard form and then finding the degree and the leading coefficient. So our first one, we rearrange, and our degree is 5. That's our highest exponent. The leading coefficient is 1 here because we do not have a number in front of that variable, so I could stick a 1 in the front. Second one, our degree is going to be 7, and our leading coefficient is negative 24. If you have questions about any part of standard form, please let me know when you get to class. Last thing we want to do is use polynomials in order to solve problems. So they're giving us a word problem from 2000 to 2006. The number B of skateboards in thousands produced at a manufacturing plant can be modeled with the equation B is equal to 3x squared minus 2x plus 10, where x is the number of years since 2000. How many skateboards were produced in 2002? And then how many skateboards were produced in 2005? So it is giving us this problem that we are trying to figure out. First thing we want to do is deal with the first question, so 2002. We need to figure out what to plug in for x. It is looking for the years since 2000. 2002 is 2 years after 2000. So when we're looking at 2002, we're going to have b is equal to 3 times 2 squared minus 2 times 2 plus 10. So when we are looking at that, we solve the problem, and that is 18. Remember, it noted that this is in thousands, so this is 18,000 skateboards. Our next question was looking at 2005, so that is 5 years after 2000, so a similar type of expression. But instead of plugging in 2, we are going to plug in 5. And that is going to give us an answer of 75,000 skateboards. You can plug this all into your calculator at once, making sure that you are being careful about parentheses and or your multiplication symbols. Go ahead and try this one on your own to figure out how many were produced in 2017. So we plug in 17 for our number. You could take the step in the middle and figure out the solution to each part, and we end up with 843,000 skateboards being produced. If you have questions about this or anything else from the lesson, please let me know when you get to class.